Hello everyone, welcome back to ptet.chemistry channel. My name is Dr. Ong. In this tutorial video, I go through this 5129 combined science tutorial on qualitative analysis. As this is a combined science curriculum, this is 3 sciences combined to 1 subject. I'm specifically going through the chemistry section of it. This is equivalent to any 14 to 16 years old GCSE, IGCSE, or O Level combined science syllabus. In these first questions, we have 2 samples of 2 grass solid. So what's very important is we started out as solid, and this solid E is covered in oil. That means to prevent exposure to the air. And the reason for doing this is because it might be very reactive to air. So this is to prevent exposure to air, which will be the oxygen. You have around 21% oxygen, diatomic molecules present in the air. Solid F is in a bottle. Do not touch with bare hand. So this can really burn your hand and stuff. Most likely this one is corrosive or toxic or dangerous if you touch it with your bare hand. Okay, so you're supposed to use glove. So these are technically chemical resistant glove because you don't want it to get in touch with your skin, so you will use chemical resistant glove. Now this student add a piece of E, and that was the one that you cover in oil because it can react with oxygen or water in the air. And this skates around the surface, so this solid float on the surface, so it doesn't sink, so it float on surface of the water, so that means it must have low density. This reminds us of a reaction of metal, specifically group 1 metal, and that giveaway is basically there is hydrogen given off, because when group 1 metal, when you add it with water, you're going to get a violent reaction, but you also get fizziness, which is your hydrogen gas, H2 gas there, and you will get an alkaline solution. Group 1 metal is known as alkaline metal, and that was from the topic on metals. Now describe the test which confirms that the gas is hydrogen, and what is the result for a positive test. So the test is basically use a lighted splint. A lighted splint is the same as a burning splint, so it's the one where the fire is still going on, so that is called lighted or burning splint. So what happens is the lighted splint will burn with a pop sound, so it produces a pop sound and the splint will go off. So the key characteristic for hydrogen gas test is that you produce a pop sound and then the splint goes off. The next bit is you put some of the solution G. So what was solution G? Solution G was what you produce after you react the group 1 metals, you get solution G. So group 1 metal will form, group 1 metal is called alkali metal, and when they react with water, they will form alkaline solution. So this is solution G, and this must be alkaline or basic there. It means that the pH is greater than 7. That's because you have a lot more OH minus ions. What is the identity of solution G? Well, you got a test here. You add some aqueous iron to nitrate and you get green precipitate. So this is a test for iron 2+, courtesy of these 2 in the Roman numeral. It means Fe2+ and O3-. So test for iron 2+, this is using your hydroxide, which will have to be your sodium hydroxide. This is from sodium plus water reaction, because NaOH there is just the metal and the water, giving you the solution G, which is alkaline. So G must be sodium hydroxide. They want the identity, so the way we write it, just like from your syllabus, will be aqueous sodium hydroxide. If you know the formula, you gotta write it down correctly. That is Na plus OH minus NaOH. You gotta include the aqueous because this is a solution, meaning you dissolve that in water and not the solid. Solid E, on the other hand, will have come from the hydroxide come from solid E, that is the group 1 metal. Since we have sodium hydroxide, we must have the sodium, and this is sodium metal. With or without the metal, it is perfectly fine there, because sodium is a solid metal, is an element from the periodic table. Suggest an alternative solution to identify solution G. Other than iron 2 nitrate, so other than this, other than you getting green precipitate, how can you identify the Na plus in G, which is NaOH? Well, we could do many things, right? We have a whole table where we use sodium hydroxide to test for iron 2 nitrate. So what we can do is we can use copper 2 sulfate, for instance. Copper 2 sulfate is a blue solution. You have seen it in the practical demonstrations. Cu2 plus, SO4 2 minus, 2 and 2. These are valency. Valency are your combining power. So your combining power based on the charges of the ions. We do the crisscross, lowest common multiple, but then you got to divide by the smallest number to get the simplest whole number ratio. Just one of the copper 2 plus, just one of the SO4 2 minus, Cu, one of it, SO4, one of it. This is known as copper plus 2 plus 2 charge of the ion, and then you call it sulfate there. Regardless, they don't ask for the formula. You can just use copper 2 sulfate solution, and instead of getting a green precipitate, what we expect to get is we expect a blue precipitate, or you can say a pale blue precipitate, which is insoluble in excess, solution G there. There are many other choices. You could go for iron 3 nitrate. You will get a reddish brown precipitate, etc., etc. So this is your qualitative analysis kind of table, which of course you are never ever given in your theory paper, except for paper 4, which is your alternative to practical. Sorry, I mean paper 3. Whatever paper it is alternative to practical. You will have access to those notes, but you don't have access to it in a theory paper like this. In this next question, we add a small piece of solid F to call water. This solid moves up and down, so it's not just floating. So this one is not your group 1 alkali metal, because only the alkali metals can float on water with low density. It fizzes vigorously, so this is a reactive metal. So it is a reactive metal. It reacts with water, and you also give hydrogen. So if it is not group 1, it's a reactive metal. So also a metal. But not group 1. So not group 1, so could be group 2. What metal are we looking in group 2? Now she puts our solution H into test tube, because this is still metal plus water. So metal plus water from the topic of metal chemistry, you will get metal hydroxide, which is alkaline or basic, and you will get hydrogen gas, which is a diatomic molecule with a covalent bond with 1 electron from each hydrogen atoms. That is covalent bonding between non-metal and non-metal in order for each atom to complete its outer shell there. Now she places marble chips in a separate test tube. She adds hydrochloric acid. This marble chip is basically your calcium carbonate. So marble contains calcium carbonate. These are from year 9 chemical formula. Ca2 plus, calcium is in group 2. They want to lose 2 electrons to complete the outer shell. When they combine with carbonate ion is also from year 9 chemical formula. You also cover it in qualitative analysis. Test for carbonate, add the acid, and you will get a gas, and this gas turns milky because there is carbon dioxide produced there. We talked about the formulation of calcium carbonate, just like copper 2 sulfate in the previous question. We do crisscross of the valency, and then we get the simplest whole number ratio. Chemical formula of calcium carbonate, 1 of calcium, 1 of the carbonate. The carbonate as a whole is 1 carbon, 3 oxygen. The charge is 2 minus. Now calcium carbonate plus acid, so you get hydrochloric acid. Then you're supposed to get a salt, carbon dioxide, and also water. The salt you get from hydrochloric acid is called chloride. You're supposed to get calcium chloride. And then you will get CO2, which is a gas, and you will get H2O, which is liquid water. These things go milky. So what is this solution that you had previously? Well, you use lime water to test for So you use lime water to test for carbon dioxide. So lime water is saturated. The word saturated is from year 9 separation techniques under crystallization. So when you prepare salt from the acid and base topic, you also heated the solution until saturated. It means very concentrated calcium hydroxide there. So if we get calcium hydroxide as the solution, the metal F must be calcium. So F is calcium. Then what is H? H is calcium hydroxide or lime water, because you use it to test for carbon dioxide, which you produce actually from this reaction of the marble chip calcium carbonate with hydrochloric acid. This question is simpler than that. They want you to bubble the gas, form into solution H, label the apparatus and the chemicals. So we have this reaction between carbonate and hydrochloric acid. So this is about collection of gas. I can use something called a gas syringe. A gas syringe was in your experimental techniques as part of an apparatus setup to collect gas. We need a stopper. If we don't have a stopper, the gas you produce here will escape. We need to have lines on this thing because this will allow you to read the volume of a gas. This is called a gas syringe. A gas syringe collects the volume of gas. To read the volume, you must have these lines to indicate that it is a gas syringe there. There should be no escape outlets because this is just a piston. As the gas gets produced, it will push the piston out and you'll be able to read it. So those are your marble chips. And you will have hydrochloric acid in there. You don't want the gas to escape, that's why you have a stopper there. This by no means is the only answer, because you could have drawn the one where you have inverted measuring cylinder, which will be like this and like that. It's not really the best technique of all simply because carbon dioxide can dissolve in water, so it's not going to be very accurate. Regardless, it's okay because you can definitely still, collect the gas in there. You want to read the volume of gas, so you can read it based on the reading on the measuring cylinder. Two different apparatus there in order to read the volume of gas there, to collect the volume of gas. So you have marble chips and you have hydrochloric acid, which is HCl aqueous, like that. And that is your measuring cylinder. We gotta label our apparatus. So measuring cylinder was straight from your year 7, the apparatus you have seen before in your entire life there. What is needed in these questions are not the identities, but the gas collection, labeling the apparatus, as well as the chemicals, the two chemicals and the apparatus, the two chemicals and the apparatus. This is or. So, you can choose whichever one you want, but this is the slightly preferred one, the one on the left-hand side. The next one suggests the identity of solution H. As mentioned, you gotta have this lime water solution to test for carbon dioxide, which you produce when you react marble chips with hydrochloric acid. So H is basically your lime water. But we know that our lime water is basically saturated calcium hydroxide solution. Calcium hydroxide dissolved in water will give you lime water or calcium hydroxide solution. And you get that solution from reacting the metal with water. It doesn't float on water, very vigorous. Therefore, it will form the alkaline solution of calcium hydroxide coming from the metal solid F. So F must be the metal calcium there. And that's the end of that 7 marks question. In this next question, so we have this teacher who gave the student 5 gas jars. So these are gas jars containing the gas. Each one has a different gas. That's very important there. All your tests for gases are from the syllabus. So we're going to read and relate to this particular table or scheme here. They are all colorless, so it cannot be halogen. So these are not the halogens. The halogens meaning to say things like fluorine, chlorine, bromine, iodine, those are colored, but they are colorless here, so cannot be the halogens. Now, does it dissolve in water? If it dissolves in water, is it acidic or alkaline? Acidic means the pH is lesser than 7, that contains more H+, whereas alkaline will be, the the pH is greater than 7, they will contain a lot more OH minus there. So sulfur dioxide, 1 sulfur, 2 oxygen. Thinks about vocabulary. Carbon dioxide is CO2, sulfur dioxide is SO2. This is an oxide of non-metal. Sulfur is a non-metal, group 6, just below oxygen. So therefore, this is what you call an acidic oxide from the topic of acid, bases, and salt. Ammonia is NH3. This is from year 9, chemical formula. Nitrogen want to share 3 electrons because you already have 5 electrons in the outer shell. You share 3 more electrons with hydrogen to complete your outer shell. Ammonia is alkaline there. If it doesn't dissolve in water, does it support combustion? Does it burn in oxygen? If it burns in oxygen, then it cannot be oxygen. Okay, so if it supports combustion, it's oxygen because oxygen is needed to burn, needed for burning or combustion. If it doesn't support combustion, does it burn in air? Yes, hydrogen can react with oxygen. It gives you the pop sound, and then the lighter splint will extinguish. Nitrogen triple covalent bond, where nitrogen share 3 electrons in its outer shell to complete the outer shell. So we have around 78% of N2 in the air. We have around 21% of oxygen in the air. We don't have hydrogen in the air, but hydrogen also exists as these diatomic molecules where it shares 1 electron with its outer shell to complete the first and its outer shell there. So we have a gas jar that has been inverted. Inverted means upside down, and you put it in there. And this student is testing if one of the gas will dissolve in water, if it will dissolve in water or not. You place the mouth of the gas jar like that. What you observe if the gas does dissolve in the water, as you remove this particular lid, the gas will go into the water. As the gas occupies the volume there, if you remove the lid and the gas go into the water, the volume in the gas will decrease and the water will go up. So we will see the water level will rises up and fill part of the gas jar. So basically the water level will go up because when the gas dissolve in water, we get lesser volume of the gas. So therefore lesser volume, or the volume in the gas jar will decrease. Lesser volume of gas in the gas jar. If you have lesser volume in there, they exert lesser pressure on the water, lesser pressure. Therefore, water level will rise up. Just like you have seen in lower secondary when we have oxygen gas being used up for combustion of a candle. Now, assuming that the gas has dissolved in water, if it has dissolved in water, now you can carry out test 2. And what is the result for an acidic gas? What's the result for an alkaline gas? Alkaline gas such as NH3 gas is definitely in your syllabus, as we had done this in practical chemistry as well. So in test 2, if we test with litmus paper, so we would use red litmus paper to test for alkaline gas. Red litmus will turn blue, has to be moist, has to be damp, a little bit wet. Whereas for acidic gas, you will have SO2 gas just now from the question earlier. Gave you SO2, sulfur dioxide with 2 oxygen on the sulfur. This is an acidic gas. So what we do with the acidic gas is the other way around. It will be the blue litmus going to red litmus there. So the result for acid gas, what do you see? So if I say damp blue litmus paper will turn red. Damp litmus paper turns red because it's acidic. Whereas alkaline gas contain OH minus, the pH greater than 7. So this is the test for like ammonia gas. Test for ammonia gas, damp red litmus paper, it would turn blue. Are these the only one you can use? Not really. You can also test with universal indicator. Universal indicator is also in your syllabus, but here we will use universal indicator paper because we have the gas there. So what happened there with the acid? In acid, so it will turn red, whereas in alkali, it will also turn blue there, or purple. Okay. Now, how would you carry out test 3? Describe the result for the test on oxygen. So test 3 is basically, does it support combustion? What is the test for oxygen? Well, we're going to use a glowing splint. So glowing splint is the one where you no longer have the fire burning, but instead what you have is the flicker. So this is just the remaining bits of the fire. And what happened with the glowing splint is it will relight in the presence of oxygen, because oxygen support combustion. So it goes back to flame again. How would you carry out test 4, which is the test for hydrogen? You would use a lighted splint. A lighted splint is the same as a burning splint. It's the one where the fire is still going on. What happened then is it burns with a pop sound. So lighted splint burn with a pop sound, and it will get extinguished. It will go off as you form water. Now suggest the names of 2 of the gases that will react together. Okay. At room temperature and pressure without using catalyst or flame. So you don't put fire on it and they will react together. So not hydrogen, because hydrogen needs oxygen in order to produce you the water. So that is 2 and 2. This is a classic primary school as well as lower secondary science. Hydrogen needs to burn oxygen to produce water. So you do need a flame there for hydrogen. So need flame. That's why it's called flame test, right? Sorry, not flame test, but using a lighted splint to test for hydrogen there. So not going to work there. We're looking at sulfur dioxide. They want the name, so we just look at that. Sulfur dioxide is an oxide of non-metal. It is called an acidic oxide. We also have ammonia, which is an alkali or a base. And what reaction do we have between an acid and an alkali? That is straight from acid, base, and salt topic. You're going to get neutralization, where you will form salt and also water. So salt and also water straight from acid, base, and salt topic, where you have alkaline containing OH minus, pH greater than 7, and now acid, pH lesser than 7. The H plus from the acid combined with the OH minus in the alkali form water, and in doing so you form a salt in this reaction called neutralization between an acid and a base there. That's it really for this work 1 tutorial, Combined Science Chemistry, 14 to 16 years old, Combined Science curriculum. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected.